Second example, to illustrate Charles' law. Let's see the example and let's bring out the solution. Example 2. A sample of nitrogen occupies 117 centimeter cube at 100 degrees Celsius. At what temperature in degrees Celsius will it occupy 234 centimeter cube if the pressure did not change? Without being told, you're told that the pressure is constant. I mean, pressure does not change. What law is this? Charles' law. Where the pressure remains constant. We have said it in that law. So we bring out our parameter first thing first. Solution. Let's bring out the parameter. Sample of nitrogen occupies 117 centimeter cube. That's what? The initial volume, V1, equals to 117 centimeter cube. At 100 degrees Celsius, that's what? T1. T1 is 100 degrees Celsius. I've told you, in Charles' law, you can't work under degrees Celsius. You must convert to Kelvin. And how do I say you convert it? You add 273 to it. T Kelvin equals to what? 273 plus T degrees Celsius. So here we have what now? 273 plus 100. So your T1, if you add that, what do you have? You have 373 Kelvin. That's the initial temperature. Let's read further. We have at what temperature? That means, in other words, at what temperature? The final temperature, T2, equals to unknown. But this time around, in degree Celsius. Please, you must be careful when you are solving your question. You read and understand the question first. In degrees Celsius, will it occupy 234 centimeter cube? At what temperature? That means that is the final volume, V2. V2 there is 234 centimeter cube. What will T2 be at this volume? We call Charles' law. Say that V1 over T1 equals to V2 over T2. We bring out our parameter. What's V1 in that question? 117 over, what's the T1? 373 equals to, what's the final volume? 234 over, what's the final temperature? T2. This simple math to simplify. Whenever you have equal to between two fractions, you cross multiply. So we cross multiply. What do we have? We have 117 times T2 equals to 234 times 373. So we bring up our calculator and we multiply our values. 234 multiply by 373. We have 87,282. So when you multiply 234 by 373, you have 87,282. And 117 times T2 will give you 117 T2. How do you get T2? Divide both sides by 117. Here also by 117. So if you divide, we're going to bring up our calculator again. We have T2 is equals to 7,282 divided by 117. So let's bring up our calculator. We have 87,282 divided by 117. So our T2 is 746 Kelvin. But that's not our answer. Mind you, we are told that at what temperature in degree Celsius. So we are going to convert this Kelvin to degree Celsius. We know the relationship. This is our relationship. T degree Kelvin equals to 273 plus T degree Celsius. So if we say T Kelvin is 273 plus T degree Celsius. So we'll put our values 746, which is our temperature in degree Kelvin, equals to 273 plus T degrees Celsius. So we move this to the other side, and when it's crossing simple equation, it turns to minus. So we have 746 minus 273 equals to T degrees Celsius. Again, we bring up our calculator. We minus 746 minus 273, and we have 473 degrees Celsius. So our T2 equals to 473 degrees Celsius. So that's our final temperature. So let's check and let's see if our answer is correct. We can see that our initial temperature here was 100 degrees Celsius and the volume here is 117. As the volume increased to 234, we are expecting the temperature to increase 473. That's what Boyce was trying to say. As the volume increases, the temperature increases, while the pressure remains constant. They are directly proportional to each other.